During this segment, we will be solving word problems that can be modeled by quadratic equations. We'll use the same steps that we've used before for solving problems. That is, first to understand the problem by reading and rereading it, and then to translate, then next to solve once we've translated to some sort of equation, and then interpret what we've come up with in our solution. So once again, it is to understand, translate, solve, and interpret. Let's look at our first application. The perimeter of the triangle shown is 85 feet. Find the lengths of its sides. And notice the three sides are marked. One side has length 2x feet, the second side has length 2x plus 5 feet, and the third side x squared plus 3 feet. We need to first recall what the word perimeter means. Remember, perimeter means distance around. So in order to translate to an equation, we use the fact that perimeter means distance around, and we find the sum of the lengths of the sides shown, set that equal to the given perimeter, 85 feet. So we'll have 2x, the length of one side, plus 2x plus 5, the length of a second side, plus x squared plus 3, the length of the third side, is equal to 85. This is then our equation. Now notice that this equation happens to be a quadratic equation. So let's solve this equation by the only method we know thus far, by factoring. First, notice I've got some like terms. I'll write x squared first. 2x plus 2x, that's 4x. 5 plus 3 is 8, is equal to 85. I don't have this in standard form yet because I need to set it equal to 0. So we subtract 85 from both sides. We'll have x squared plus 4x, and then 8 minus 85, that's negative 77, is equal to 0. And now we'll solve this quadratic equation. We'll factor this trinomial on the left side. I'll let you check the factoring, but it factors as x minus 7 times x plus 11. We then set each factor equal to 0 and solve. Here we add 7 to both sides and we get 7. Here we subtract 11 from both sides and we get negative 11. Now it's true that this quadratic equation does have two solutions, but remember the context of our application. We're talking about the length of the sides of a triangle. One length was 2x, and from there we had two other lengths. So we cannot use negative 11. That would give us a negative length. We will not then, in the context of our application, use the solution to this equation, negative 11. We'll only use 7. And now let's use 7 and get to the lengths of the sides of the triangle. Remember, one length was side 2x, which in this case is 2 times 7, which is 14, and then we were in feet. Also, a second length was 2x plus 5, which is 2 times 7 plus 5, 14 plus 5, that's 19 feet. And the third length was x squared plus 3, which is, let x be 7, 7 squared plus 3. That 7 squared is 49, plus 3 is 52, so that is 52 feet. Here are the lengths of the three sides of our triangle. Now, how can you check? And I'll let you check. Find this sum. This sum, which represents the perimeter, should be 85 feet. Then make sure this is double this, and this is 2x plus 5 again, and this is x squared plus 3. But here we have solved our application. Let's look at another one. An object is thrown upward from the top of an 80-foot building with an initial velocity of 64 feet per second. The height h of the object after t seconds is given by the quadratic equation h is equal to negative 16t squared plus 64t plus 80. When will the object hit the ground? Let's remember what this equation means. Remember, t stands for seconds, that's time in seconds, and h stands for height of the object in feet. So, for example, when time is 0, if I let time be 0, I'll have negative 16 times 0 squared plus 64 times 0 plus 80. The height of the object at time 0 is 80 feet. And that should make sense because we were on the top of the 80-foot building and then we threw it upward. All right, and you can look at the time when t is 2 seconds, when t is 3 seconds, and so on and so forth. The height will increase and then at some point decrease, and we're interested in when will the object hit the ground. Well, when the object hits the ground, what is the height of the object? When the object hits the ground, its height is 0. So, to answer the question posed to us, we are interested in finding t when h is 0. So, we need to solve this quadratic equation. Now let's just concentrate on this quadratic equation a moment. How do you solve a quadratic equation? You write it in standard form as it is because this side is 0, and now you factor the other side. There is a common factor of 16. As a matter of fact, I'll factor out negative 16, and I'll let you check by multiplying, make sure I'm correct. And then if you concentrate on the trinomial, t squared minus 4t minus 5, I'm looking for two numbers whose product is negative 5 and whose sum is negative 4. So those two numbers are negative 5 and a positive 1. Factored completely. Remember, you said each factor containing a variable equal to 0. In other words, I don't need to set negative 16 equal to 0. That's an equation that has no solution anyway. So I'll set t minus 5 equal to 0 or t plus 1 equal to 0. Here I'll add 5 to both sides, and here I'll subtract 1 from both sides. So let's make sure we have this straight. This equation does have two solutions. One solution is 5, one solution is negative 1. But now let's think about the question posed to us. We're interested in time when the object is on the ground or hits the ground. Okay, a time of negative 1 second would make no sense in our application, so we'll reject this possible solution of our application, and our actual solution is 5. So in 5 seconds, the object will be thrown upward, go up, back down, and hit the ground. You can check by letting t be 5 here and here, and seeing that the height then is 0. It will be. Our next application has to do with the Pythagorean theorem, so let's review that theorem. Remember, it has to do with right triangles. In a right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. In other words, leg squared plus leg squared is equal to hypotenuse squared. And of course, we're talking about lengths there. In other words, if A is the length of a leg, and B is the length of a leg, and C is the length of the hypotenuse, it is true that A squared plus B squared is equal to C squared. Now let's look at our application. One leg of a right triangle is 4 millimeters longer than the smaller leg, and the hypotenuse is 8 millimeters longer than the smaller leg. Find the lengths of the sides of the triangle. So let's go ahead and if you need to, by the way, read and reread until you understand. Then I'd like to translate to an equation, and I will do that using the Pythagorean theorem. I will let x represent the length of the smaller or shorter leg of our triangle. Notice the other leg is 4 millimeters longer, and the hypotenuse is 8 millimeters longer than the shorter or smaller leg. You may want to take a moment to help you translate to an equation and draw a right triangle. Label the lengths of the sides. This is the shorter leg, or the length of the shorter leg, and I'll denote that by x, an unknown. Then remember, we were given that the length of the longer leg is 4 millimeters longer than the length of the shorter leg, so I can represent that by x plus 4. Then the length of the hypotenuse, which is across from the right angle, that length is 8 millimeters longer than the length of the shorter leg. So that is x plus 8. And now we'll use the Pythagorean theorem to help us translate to an equation. Do not forget, in the Pythagorean theorem, it's length of leg squared plus length of other leg squared is equal to hypotenuse squared. All right, so length of a leg squared plus length of the other leg squared is equal to length of the hypotenuse squared. There's our equation we'll solve. That is x squared. Now be very, very careful. This is a binomial squared. If you need to, go off to the side, write it twice, and use the FOIL order for multiplying. But it's x plus 4 times x plus 4, so it's x squared plus 8x plus 16 is equal to, same thing here, go off to the side if you need to and write down x plus 8 times x plus 8, because there will be a middle term. It is x squared plus 16x plus 64. Notice this is going to be a right triangle, this is going to be a quadratic equation. So we'll write it in standard form, setting it equal to 0. I have x squared plus x squared minus x squared. That's 2x squared minus x squared, which is x squared. Then I have 8x minus 16x. That's I have x squared plus x squared minus x squared. That's 2x squared minus x squared, which is x squared. Then I have 8x minus 16x. That's minus 8x. And then I have 16 minus 64. That is minus 48 is equal to 0. I'm going to go ahead and factor this. If you need to take longer, don't worry about that. No problem. But this factors as x minus 12 times x plus 4. We'll set each factor equal to 0. X minus 12 is equal to 0, or x plus 4 is equal to 0. Here, I'll add 12 to both sides. Here, I'll subtract 4 from both sides. So this equation does have two solutions. One is 12, the other is negative 4. Don't forget, though, in the context of this word problem, x stands for the length of the shorter leg of the triangle, so it will not be negative 4, and we must use 12 only. So the length of the shorter leg is 12. Remember, we are in millimeters. Then this is 12 plus 4, or 16 millimeters. And this is 12 plus 8, or 20 millimeters. How can we check? Make sure these links satisfy the Pythagorean theorem. Find 12, square it, then find 16 and square it, 16 squared. Find that sum and make sure that sum is 20 squared or 400. But there's our application dealing with the Pythagorean theorem. Now let's look at the following. The sum of a number and its square is 182. Find the number or numbers. Now let me read this carefully one more time because this will tell us how to translate to an equation. We'll let x be our unknown number, the sum of, and this is our unknown number, and its square is 182. Find the number or numbers. Can you see that this will be our translation to an equation? The sum of a number and its square is 182. To solve this application, we first solve this equation. It is a quadratic equation. I'll write the x squared first, then plus x. I'll subtract 182, set it equal to 0, and now let's factor. You may need to work with 182 for a while, but we're looking for two numbers whose product is negative 182 and whose sum is the coefficient of x, which is 1. Those two numbers are 14 and negative 13, but again, you may need to work with that a little bit. So 14 and negative 13. Once we factor, we set each factor equal to 0 and solve. Here I'll subtract 14 from both sides and we have an answer of negative 14, and here we add 13 to both sides, so it looks like we have two possible solutions. Now, if this is my unknown number, how do we check it? Is the sum of this unknown number and its square, what is the square of negative 14? It's negative 14 times negative 14, or 196. That is 182. How do we check this possible number? Is the sum of this number plus its square, 13 times 13, is 169, and that is 182. So make sure you understand these are two possibilities of numbers we are talking about. So there are two solutions. One solution is negative 14. The other solution is 13. Let's look at another application. This application has to do with consecutive numbers. The product of two consecutive page numbers is 420. Find the page numbers. So once again, notice it's a product of two consecutive page numbers is 420. We want to find the page numbers. So if we let x be one page number, what is the next consecutive page number? And by the way, we're just assuming that x is a positive integer since it is a page number. So what is the next consecutive page number or integer? Well, it increases by 1. So if x is one page number, the next page number is x plus 1. Then remember what the problem says, the application. It says the product of two consecutive page numbers, product means multiply. The product of two consecutive page numbers is 420. Find the page numbers. Well, we have an equation now to solve since we've translated. This is a quadratic equation because I have x squared plus x times 1 is x. I will then subtract 420 from both sides, and I've written that quadratic equation in standard form. Now remember, we try then and factor. in this case, a trinomial. It is factorable. I know you may need to work with it a little bit, but it does factor as, and by the way, don't forget you're looking for two numbers whose product is negative 420 and whose sum is a positive 1, the coefficient of x. Those two numbers are 21 and negative 20. That product is negative 420 and the sum is 1. Now, how do you finish solving this quadratic equation? You set each factor equal to 0, and then you solve. Here, I'll subtract 21 from both sides. Here, I'll add 20 to both sides. Now, these are not our two-page numbers. These are possibilities for x, which is one-page number. I will not use negative 21 as a page number because we're assuming our page numbers are not negative. I will, in fact, use 20 as one page number. So then what is the next page number? The next page number is 20 plus 1, or 21. Here are our consecutive page numbers. Remember what it said? They are consecutive page numbers, so we're okay there. And the product is 420. I'll let you check, but that product is 420. So there are our page numbers. At this time, make sure you can solve quadratic equations so that once you translate to an equation, the solving will not give you trouble, but also make sure, because these are applications, that you correctly interpret the results of solving.